Okay, so now let's move on to question number 7. What is the Lewis structure of NH3? Okay, so this is a multi-step question. So I'll just go over it one by one. The first step is to find the total number of valence electrons. Okay, so let's see what we have for nitrogen. For one atom of nitrogen, there are 5 valence electrons. And then for hydrogen, each hydrogen has 1 valence electron. And since there are 3 of them in NH3, I'm going to multiply this by 3. So we end up getting a total number of 8 valence electrons. Okay, so step 2 is just to connect atoms. So just since we're given NH3, on the right here, I'm just going to draw my nitrogen. And then I'm going to draw out my 3 hydrogens. And you'll also notice that there is a single bond between all of them. And each bond involves 2 electrons. So I'm going to take note of that, where each bond involves the sharing of 2 electrons. So let's look at how many electrons we have drawn so far. So if we count out that there are 3 bonds, that means there are 6 electrons involved. But since we counted out a total of 8 valence electrons, this brings us to step 3, which is to assign electrons to your terminal atoms. So in our case, this is hydrogen, but hydrogen can only have 1 electron involved. So you'll never see hydrogen have like a lone pair or anything. I'm just going to put in brackets none for hydrogen. But for step 4 is to assign electrons to the central atom. So we need 2 more electrons for NH3. So I'm gonna put them on my central atom, which is the nitrogen. So all of our electrons should be accounted for, but I'm still gonna write down the last step, which is when if you have no unassigned electrons, but your central atom doesn't have an octet, this is when you can make double or triple bonds. So in our case, let's look at the nitrogen. It has 2 electrons as a lone pair, and then it has 3 bonds attached to it, each bond involving 2 electrons. So that means it has its octet. So this is our final Lewis structure for NH3. So let's see what our junior tutor said. The Lewis structure of ammonia, NH3, is 3 hydrogen atoms bonded to a nitrogen atom, which is in the center, with a lone pair of electrons on top of the nitrogen atom. The Lewis dot structure represents the arrangement of electrons, shown as dots, between atoms in a molecule. The atoms must follow the octet rule or the tendency of atoms to prefer to have 8 electrons in the valence shell. The individual formal charge of each atom as well as the overall formal charge of the molecule must be satisfied. So in drawing the electron dot structure of ammonia, step 1, draw the skeletal structure of NH3 with nitrogen at the center. Step 2, calculate the total number of valence electrons in the molecule. So this is what we did first, where you had the number of valence electrons in nitrogen plus in hydrogen. They got 5 plus 3 equals 8. Step 3, distribute the electrons as dots. Note the octet rule must be satisfied for nitrogen. However, hydrogen can only share 2 electrons. Step 4, replace the 2 electrons with a single bond between nitrogen and hydrogen. A lone pair of electrons will be left at the top of the central nitrogen atom. Okay, so we had similar rules, but just in like different orders. So it just depends on what method you feel comfortable with doing. But overall, this solution is correct.